Let us go ahead. I've been saying that the first property we are considering a triangle ABC is similar to a triangle XYZ because the angle A and the angle X are equal, and the angle B and the angle Y are also equal. Even the angle C and the angle Y are also equal. The angle A and the angle X are equal. So you find the A is 90, X is 90. And the angle B and the angle Y are equal. So you find that angle B 30 and the angle, this is the angle Z, the angle X, Z, Y. It is X, Z, Y. So you find that the angle, let me change here. The angle A, B, C is equal to the angle X, Y, Z. That is it. The angle ABC is equal to angle XYZ. And the angle ACB, angle AC, angle AC, then B. So it is C will be equal to Z. So angle ACB is equal to angle X, Y. It is not Y, it is X, Z, Y. It is X, Z. It is X, Z, Y. So to correct this clearly, to be angle ACB is equal to angle X, Z, Y accordingly. So this one we obtain from this triangle, we find that angle B is the same as angle C and BC is the same as YZ. Since this line is horizontal and this one is horizontal, then this line BA and the Y is X, those are slanting lines. So since they are slanting lines, you find that the angles here are the same with the angles there. Then so the XZ and the SC are also the same lines of the same length. So we can talk of the first property, which says this first property here says the angles of one triangle. So the angles of one triangle, this first triangle, are equal to the corresponding angles of the other triangles. So the angles on this triangle are equal to the angles of the second triangles. As we see that we have the angle of B is 30, the corresponding angle on the other triangle B, which is the Y, is also the angle A, which is 90, the corresponding angle on this triangle X is also 90. So this first property says that the angles of one triangle, the angles on this triangle, are equal to the corresponding angles of the other triangle. So the angles of this triangle are equal to the corresponding angles on this triangle. So we find that we can proceed with the second part, or the second property, which says the corresponding sides and the corresponding sides are all in the same ratio. So the corresponding sides are all in the same ratio. So these sides, now consider the triangle KLM is similar to triangle TUV. So these are two triangles which are similar because we find that KL divided by TU. So if you get KL divided by TU equals LM divided by UV equals KM divided by TV equals 2 divided by 3. This comes from the property B, which says the corresponding sides are all in the same ratio. But if you get the side KL from the first triangle, KL, which is 3, we divide by the side TU. The side TU is 4.5. So if you get 3, divide 3 here, divide by 4.5, the answer we get shall be equal to the side LM shall be equal to the side LM divided by the side UV of the second triangle. So we find that we have LM as 4 divided by UV as 6. So if we divide, we get the same answer as someone who says KM of the first triangle, KM divided by the second triangle, which is TV. So if we get the value of which is KM as 5, we divide by TV as 7.5, we get the same answer. So we get 2 over 3. So this 2 over 3, we have the name we give it. We name it as a linear scalar factor. So this linear scalar factor, here, it brings a relationship between two similar sides of the similar diagrams. So now we have these two angles, and also have a note here, and also it can be KL divided by TU. So KL divided by TU is the same as LM divided by UV is the same as KM divided by TV is called a linear scalar factor, in bracket LSF. Linear scalar factor, which deals with sides. So that one, whenever we have this content, we shall be dealing with a linear scalar factor, which will be helping us to get the similar sides, like LM divided by UV. If you get these two similar sides and divide them, you will obtain what we call the LSF. That is a linear scalar factor. So from there, we have property